Good afternoon, folks. All right, so last time we were talking about SQL, so we should continue that. Replit was down, so we decided to use XAMPP. It's back up now, so we can go back to using SQLite, which will make testing your code and turning it in a lot easier. All right. So we had this information. And we were pulling this data from the data in the assignment, I believe. So let's go to that. All right. So the starting point here has the tables set up. It has the records entered in. And published. Okay, so SQL1 exercises, which was due November 2nd. But if you're still working on it, you can turn that in still. Looks like only 5 people have turned it in. All right. And this video demo. Okay. So you guys should be able to figure this out. Write the select statement to do these certain things. If you need help with that, let me know. But today, what I want to talk about first is stuff that we didn't go over in the first PowerPoint, like the insert into statement, update statement, and delete statement. Okay, let's start with update and delete. Those are, oh no, we already went over insert into. This is how you insert records into your tables. Update, oh, and I think we talked about delete. No, we talked about delete table. Well, I'll mention it again. So update, the update statement. This is what it looks like. This is the structure of it. And let's go ahead and put in some information here. We'll say, so the top one is just the syntax. You would replace the italics with the names of things. Okay. Forgot to open my chat. There we go. All right. So let's look at this update statement, and I'll give you an example here, and then we'll do one in the SQLite database starting point from the exercises. So we're going to update the students table. We're going to set name equal to Bob. We can do, other things. We'll set, let's call this f name. We'll do L name equals Smith. All right, so that's the set part. And this last part is extremely important. Can you guess what will happen if you just run this command as written? If we set update students, set f name to Bob, L name to Smith, what this will do is go to every record in the table and change the f name to Bob and the L name to Smith. Okay, rarely do you want to do that. In that case, you probably never want to do that for this field. So how do we limit it? Well, if you only need to change one record, using the primary key is a good idea. So we'll set where student ID equals whatever number you want. Okay, and so this is, I just made this up. None of this is real, but this is what an actual command might look like for updating. So what this says is, in the students table, we're going to set f name to Bob, the f name field, to the string value of Bob, and the last name field to the string value of Smith. All right, but only where the student ID field is 34789. So it should only change records that have this student ID. Okay, and like I said before, if you don't include the where part, it'll just hit everything in the database. So sometimes it's fun to actually see this stuff happen. So right after this, before we do the select all, which I think is the last thing here, select star from section, select star from students. Take a look at that. And I think I'm going to duplicate this so I don't mess up the starting point. There we go. All right. So what is the table called for students? Here it is. It's called student. So let's select star from student. And that should show us all the student records. So this looks like it's their last name, their student ID number, their major, and whatever this number is. We would have to look up what that was. So let's go back to student and see what the last one is called. Total credits. Okay, so it looks like this guy's been in school for a while, 102 credits. Maybe he's going for a master's or a PhD. 110 credits, and then down here 120. Or maybe they changed majors, so they had to redo a lot of stuff. All right, and then the other thing here is, this is kind of hard to read, right? And we don't have the table headers. Do you remember how to set that up in here? Well, I don't remember off the top of my head, so I'll just pull up the one that the demo we had before. MyRepls, and I want to search by SQLite. And so we have intro. I believe we figured out how to set it up, the display better in here, which just requires you to change some configuration variables, and we did that here, right above where we start before we printed it off. So we want headers on and mode column. Okay. So right before our select statement, we can turn on this. We'll put adjusting output. Oh, I already had that in there. Okay. Okay. And then it'll look like this. That's a little easier to read and understand, right? Okay, so let's try update student set name to Bob. And then we'll select all those. So here we've accidentally changed everyone's name to Bob. Probably didn't want to do that. So how can we fix that? Let's say we only want to change whose name. Okay, we're going to change Levi's name to Bob. Maybe he had a name change. So copy that. And remember I said you just have to put a filter on it, and we do that with the keyword where name, or no. We don't want to do name. Why is that? Why would you not want to change Levi, or set the name field to Bob where name equals Levi? Why do you think you don't want to do that? It'll work in this case, but what could happen in the future that would really cause us problems? Let's add another Levi and see. So first we'll say, we'll go ahead and do it so you can see that it works. Update student, set name equal to Bob, where name equals Levi. And for some reason it's not working because it's a capital L. So remember, the commands in SQL are not case sensitive, but the data is, especially strings. I think only strings, right? Because there's no capital numbers. Okay, so there, now we change Levi to Bob. That was the only one that changed. That's fine, right? Let's add another Levi in there, and then you can probably guess what's going to happen. So where we're inserting the students, instructor, section, teaches, student. Here we go. We'll go ahead and throw in a couple more students. Levi. They need different IDs because we don't want anything to have the same primary key. Okay, and then this one we'll give a major of books, and this one a major of pencil sharpening, so we can see them easy in the output. Okay, and so here we can see we added these as Levi here and here, but their name got changed to Bob because we're only looking for the name of Levi. So what should we use instead of name or department or total credits? We can't use those if we're just trying to change one student, because other students can have the same values for those fields. So we don't want to use name. If we only want to change one, we should use the unique identifier, the primary key, and we only want to change the physics Levi, 4, 5. Where is it? 6, 7, 8. Wow. The only one that's in order. Well, it's easy to remember. Okay, and so now these Levi's are unaffected, and only this one is. Okay, so if you want to update one record, which usually you're going to want to only update one record. Can you think of an example where you might want to update multiple records? Well, if we add another column, we'll need to update it. So in part 2 here, I mentioned this, but I'm not sure if we did an example. There is slide 24 is how to add a new column. Okay, you alter table, name of the table, and then just like when you create a table, you reference the name of the field and the data type and any constraints you want. So we'll use this. Be careful about copying out of Microsoft Office software. Double quotes are different in those, so you have to replace them if you do this. There aren't any double quotes in here, so we're fine. All right, so we're going to alter table students, add a grade field of 2 characters. So we're going to put the right student name. All right, let's try this. And now look, we have a bunch of empty grades. Okay, so maybe we want to set those all to something that signifies the grade hasn't been calculated yet or something. We'll just use UG for ungraded. How would we just add that to all these records? What do you think? I want to change every record, but only the grade field. We just need the update statement. So we can update the student table. We're going to set grade equal to UG. All right. And so we added the new column and we filled it with a value that we want to use. In 2 steps, I think we can do, let's see if this works, default UG. So let's not use update, let's use this default. Okay, what's happening here? What does default do again? We did use that last time, or we talked about it at some point. What is default and what does it do? Well, it's in the slides. Default. I thought it was in here. There it is. So it says, the default constraint is used to insert a default value into a column. The default value will be added to all new records if a value is not specified. So if we add a column, it's going to be empty, but it uses the default instead of just making it empty. So we set the default to UG, so that gets added in there. All right, and we look. This allows us to change a table. All right, let's say we want to get rid of that. We can do alter table student. Is it delete or is it drop for columns? Let's see. Yeah, drop column. So you'll see fields have a few different names. Sometimes they're referred to as columns, sometimes they're referred to as fields. They're also referred to as attributes. So it's tricky to understand that those are the same thing. So how do we get rid of this? We do drop column grade. And now alter table student, drop column. Oh, no, that's right. It might be different in SQLite. Let's check the syntax. So adding worked the same. Okay, and if you end up getting onto Stack Overflow, remember how to use it. You have to understand this first part is the person with a problem and they're asking their question. So here, they want to delete or add a column. Okay, that's what we want to do. So we should look at the answers. And you want to look for the one with the green check mark. That means the person that asked it was able to fix the problem using this answer. 365 people agreed versus the next highest was 47. So we'll probably go with this one. Okay, so in SQLite you cannot rename a column, remove a column, or change any of the constraints of any of the fields on a table. So you just have to do the extra step of creating a new table the way you want it, and then copying all the data between the two, which we will look at how to do. Copy data from one table to another. We will see that. It's not as easy as just dragging something from one place to another, unfortunately. But the commands aren't that complicated. All right, let's go back. Okay, so we looked at the update statement. I already talked about the delete statement before. If you don't include the filter here, it will just delete all the records. So let's go ahead and just show that because it's funny. It's not funny when it happens to you, but it's kind of a ridiculous thing to do. So now, we can't do this, so we'll just get rid of it. You can do that in MySQL. So if you were using XAMPP to run a query, you could use that. It probably has to do with the way the data and the tables and everything are logically stored. Probably makes it really difficult to do that. Or just they have a different way to do it. Okay, so we want to do delete from student. All right. So now it doesn't pull any records because we just deleted them all. But let's only delete the records where name equals Levi. Oh, whoops, we don't need that there. Okay, now all the Levi's are gone. But we changed Bob's name or Levi's name to Bob first, so he's still in there, obviously. If we did it this way, we did the delete first, what's going to happen? We're deleting all three of the Levi's, and so it can't find this one, so it doesn't do anything. All right. So that's the delete. It's for getting rid of records. Update is for changing fields in a record. And this alter table add, this is for adding a column. Okay, what's next? So we're just filling in a few things that I haven't mentioned yet. Alright, we're done with everything on SQL Part 1. And we'll do SQL Part 2 here. Making a note to myself here so I don't forget. Okay. So part 2, we looked at how to create a database, which you don't need to do in SQLite, but you do need to do in MySQL. Creating a table is similar in both. We looked at that. And in the assignment you can see numerous examples of this. Okay, we talked about that. Let's not worry about that for now. Data types. Okay. The date data type. So one important thing about the date data type is some databases keep a log of transactions, and they need to know when those transactions occurred. So here, if we do timestamp or date time, we get the year, the month, the day, the hour, the minute, and the second. So let's create a field. Am I editing the wrong one here? No, I'm not. Okay, good. Let's go ahead and add another field to the student table, and we'll call that field registration date. We'll call it reg date. Okay, and let's set, well, we want it to be the timestamp data type. All right, and we'll set the default. We can use a function to pull the time at the moment of creation. And so you can use these functions. These are specific to MySQL. We'll see if they work here, and if not, we'll find the one. So you can use now, and that will grab the current date and time, and then we'll store that in the timestamp field. So our default will now be now. Let's see if it works. Might not work. Alter table student, add blah, timestamp. Okay. Let's double check this, because it's mad at line 264 here, which means it probably doesn't recognize. Oh, and it says near open parenthesis, which here's the only open parenthesis, so it doesn't recognize this function. So let's see how you do it in SQLite. Get current date / time in SQLite. Here we go. Oh, it's called the datetime function. Well, that's nice. Okay, so we'll set the default to datetime function. So when you see this, this is a function, which means the computer will follow a set of instructions from somewhere else, and it will give you a value, usually. So in this case, it's going to give us the date time of when the record was created. And so we're going to create the record when people register, or I guess when we process their registration. And that's also not working, so let's double check here. Oh, you have to specify now. Okay. So it's the similar idea as MySQL, it's just formatted differently. So if you tell it, I want the date time now, like this, then it should grab it. Let's see. Nope. Okay. I guess I have to include these other parts too. -1 day and local time. So what do? The -1 day modifier. Here's some examples. Okay, now local time. Select date time now. Here we go. Current timestamp. Okay, so we don't need the function. It has a field that's already grabbing that. Okay, that makes a lot more sense. All right. Third time's the charm, right? Or what? Are we up to 7? Cannot add a column with non-constant default. Okay, so it's not going to let us do it as a default, even though I think in this example it did it. Oh, they're storing it as a text data type, not as a date time, or as a timestamp. All right, let's do varchar. 8th time's the charm. Nope. So I guess this example from the official, whoa, did I forget the underscore? No. I guess it says text. Oh, but they're creating the table. I'm adding it. That's right. Okay, so let's, instead of adding it using alter, let's do it in the actual table creation statement for the student table. There we go. And so we want to add another field called reg date, and there. It'll have a default value of current timestamp. Let's see. And I think we'll go back to timestamp data type. It might not work. Okay. So now when we're doing the insert intos, we have to add new values for all those. Okay, well, let's just create our own table. I don't want to have to change everything in here. It's a waste of both of our time. Okay, we'll just create a new table to hold this, and then we'll write a couple insert intos. We'll create a, well, let me see if I fixed it. Okay, we'll create another table here, and we'll call it transaction. Nope, transaction is a keyword. We can't do that. So let's call it action. Nope, that's a keyword too. Wow, interesting. I didn't know those were keywords. Let's call it log. Call it, okay, I'll call it Apple. I know that'll work. All right. Yeah, you can waste a lot of time trying to think of a variable name. Apple is not a keyword yet, so we can use that. All right, so let's set one field of timestamp. such table. Here, create. Line 59. Why does that matter? Oh, don't forget your parenthesis. No such table takes. Oh. This must be causing an error somewhere in here. Maybe we do have to use varchar. No. Okay, maybe we'll try text. What am I missing? Seven. We have one field. That should be fine. Did I copy something incorrectly? Oh, did I forget to take that field I tried to add out of here? No. Did I mess something up in here? Oh, yeah, I got rid of the... No, it's there. This is what I get for trying to create a table. What if I don't put default? Wow. Well, let me put that back. And if we take this out, let's make sure it's not something else that I broke. No. Let's create this table first. Let's see. Sometimes there's some weird stuff when you copy and paste sometimes, so I'm going to do this. Let me try making another table of something else. Okay. All right, now I'm not getting any errors. Okay. Anyway, did it work? I guess we'll never know unless we take a look at what's in it. So let's see, Apple. Okay, it says it's empty, and that's right, we haven't added any records yet. Okay. Let's do... We'll need to provide another field, I guess. Because a date by itself in a table doesn't mean anything. Okay, so we'll just call it ID. And we'll just use int, and that's all. Okay, and we'll go ahead and make that the primary key too, so that we can, well, let's just try it without it first. Okay, so we created the table. Now we have to insert the values in. So we insert into Apple. Values. And since we're only inserting into one field, we're just going to insert IDs. It should use the current timestamp as the default in the other field. But we have to, if we're only using if we're using less than all of the fields, or in a different order, we need to specify after the table name which fields we're entering into. So we want to enter into ID. And so now we just have to provide some IDs. Okay, we'll just have 3 here. All right, finally. Wasn't supposed to take this long to show this. Usually working with date time is one of the more complicated data types, which you can see now. 11:09, that's what time it is, or day, that's what the date is, 2020, November 9th, and it's 3:16, and so apparently it thinks it's 21:16, which is what time? 21 minus 12 is 9, so it thinks it's 9:16. It might be using a different, we might have to set the time zone differently, I'm not sure. Well, we got, let's figure it out before we move on. SQLite, setting, time zone. It's the only thing I can imagine. Where's 3-hour difference from us, though? Oh, it's in GMT. Okay, so you probably just have to... Okay, another Stack Overflow with the exact problem I'm looking for. So answer. Oh, we never set it to local time. Right. Default. Oh, we already tried to do this, didn't we? Okay, well, I can look into that more later. All right. I'm more used to how to do it in MySQL, which is much simpler. All right. That doesn't always mean it's better, though. All right, so we have the date. We looked at the date data type, and now let's take a look at some other field constraints. I specifically wanted to go over these two, primary key and foreign key. Okay, so you know what a primary key and a foreign key is. Primary key uniquely identifies a record. A foreign key is a field that references a primary key in another table. And you don't need to set these constraints to use these as primary keys or foreign keys, but if you don't set the constraints, it can lead to problems down the line. So let's see if this example has any foreign key set up. So here we have a department table which lists the departments and information about the departments. Okay, and they've set it up so that no two departments can have the same name, which kind of makes sense. Why would you have two departments with the same name? I don't know. And in courses, they also have department name here. So we could use that as a foreign key. And so let's pull the information from department and course real quick. Department. Okay, and we'll pull up the information for course. So here's our departments. And then here are the courses and which departments they're under. Okay, over here. And so, if we want to set up a foreign key constraint, well, let's talk about why you would want to in the first place. So let's say you want to know, you want to write a query that's going to find, based on a course, what building that is going to be in. All right. Well, the course table does not tell you where the building is, right? But and I'm just realizing now, we haven't talked about joins, have we? We need to look at that before we can do this example. Okay, well, I think I can finish my example before we do this. Anyway, you guys know what a foreign key and a primary key are, okay? You just don't know how to use them in SQL yet. All right. But using a field as a foreign key does not require you to set up the foreign key constraint. All it does is prevents any records that are relying on records in another table. So for example, a primary key linked to a foreign key from being deleted so that we have just empty information. So if we wrote and I'll go over more detail about how this works. So we do select. We want to grab the columns of title. So course.title as our first column. And our second one, we want to grab department dot building, because we want a result of telling us which building each course is in. Okay, and those are in two different tables, so we have to connect those two tables together. So I can do from course dot department name. No. This is where we put our tables. From course join department. And before I follow through and make you guys watch me troubleshoot this, let's just look up for sure the join syntax of SQLite. We just want the syntax. That's all we want. So we're going to use an inner join. So we're going to do from the first table, inner join the second table, and then we have to provide the primary key that links to the foreign key. Okay, that will be our from. And I'll go into more detail on this later. We just have to set this up so you can see the foreign key constraint. Okay, so let me put this down here so I can see. Okay, so from course, we're going to do an inner join on department. We're going to join those two on these two fields. Inside of course, we want to find course dot well, they both need to be department name. So course dot department name, because that is the field that they have in common. Department name is the primary key of department. Department name is the foreign key in course. oops, not course again. This time we want department dot dept name. All right. All right, so here now we have the result. Oh, whoops. I left this in here as a mess. Okay. Okay, so this third, let me clear this and run it. It's getting confusing. There we go. Okay, so we're pulling the department table here, the course table here, and then here we're creating a temporary table just to see what courses are in what buildings. Okay, so we could do it this way. We could say genetics is under the biology department, and then we have to go to this table and say, well, biology is under Watson if we just grab these two tables. No one's going to want to do that. No one's going to want to pull all the data from two and then cross-reference it manually. That's why we have foreign keys. So we tell the computer, in this case, hey, grab these two fields, right? In the select, you put which fields you want to access. Sorry, I'm just trying to make this easier to read for you. There we go. Select these two fields from the combination of these two tables, but combine them in such a way that the primary key and foreign key are connected in using this. Okay, anyway, we'll go over more detail about how that works. What this does is shows us which building or which courses in which building. That's fine. This is all just set up to show you that what happens if we delete one of the records in department. Okay, so let's delete the biology department. How would we do that? So we want to do it before we pull it. Well, let's do it after. No, let's do it before we pull the information. Okay. We want to delete from department where dept name is biology. So what will that do? That will remove every row from this table that has a department name of biology. Okay, let's see that. Let me clear it and we'll do that. All right. Delete from department. Where department name equals biology. Okay, so it's not working. Oh, that's because I'm printing it out before. Okay. It is working. You got to keep track of what order you're doing this stuff in. So it was printing out before I did the delete. So if we do it now, okay. Let me clear it again. When we're pulling multiple tables, it gets confusing. Okay, so here there's no longer a biology department. Do you see a problem in the next table? There are 3 biology courses still in here, and we're saying they're under the biology department, but we've deleted that. So, what building are these in now? Well, it doesn't even show them down here because that department name doesn't have a building. So now this information here is just floating in there, and it can cause problems when we're combining tables and pulling the information out, and it doesn't link to anything anymore. So I think these are called like orphan rows or something. Anyway, it's easy to fix. It's easy to prevent by setting the department table, I think it already has primary key department name. We need, in the course table, to set a foreign key of department name. So let me check the syntax on that. SQLite foreign key constraint. Okay, so the way you do that is right here at the end of the, once you've defined all the fields, and you should probably do it after you define the primary key, you specify the foreign keys in the table. Okay, and so you use the name of the field inside this table, and then you have to put references the name of the other table's primary key. Okay, in this case, they have an artist table and a track table. Under artist, they're calling the field artist ID, and under the track table, they're calling it track artist. The names don't have to be the same, but the data types do. That's why we have to specify the fields here. Okay, so let's copy this so we can just fill it in with the information we need. So where should I put this foreign key constraint? Should I put it in department or should I put it in courses? So we're setting the primary key to department name inside of department. It wouldn't make any sense to set that as the foreign key in that table. It is a foreign key in the course table, so that's where we're going to put it, right here. And we want to say the foreign key from this table is department name, and it's referencing department table's department name. So in this case, they do have the same name, but they, like the example showed, they don't have to be. Okay. And let's clear that out. Let's see what happens. Foreign key department name references department's department name. Okay. So when we go down here to delete, where did I even put that stuff? I must have put it, oh no, right here. Delete from department where department name equals biology. Really should not, okay, should not have let me do that. And attempting to insert a row that does not correspond to any row in the artist table will fail, as will attempting to delete a row when there exist dependent rows in the track table. If the foreign key column in the track table is null, no entry is required. So why is it not working? So in their example, they have 2 artists and 3 different tracks. The first artist did the first 2 tracks, second artist did the third. And so they're trying to do, no, we don't care about insert, we want to look at the delete. Oh, they don't have a delete example. It is not possible to manipulate the database to a state that violates by deleting or updating rows in the artist table. So here it says they try to delete Frank Sinatra, but since there is a record here, it should throw an error that says attempting to delete the artist record for Frank Sinatra fails. Alright. And so that's what it should do, and I'm probably missing a part here. So when I run this, trying to delete the department name here, which is tied to the department name here. Let's make sure we have that right. Let's go back and double check that we got the foreign key constraint right. Maybe we'll look at a different source. So the name of the reference is that. Well, let's try inserting one that doesn't have a department, and we'll see if it works that way at least. Oops, not that one, this one. It is deleting it, which is a problem, and it's not supposed to. I'll have to look at that if we run out of time here. So let's try inserting another department. No, we want to insert a new course. That's what we want. So we'll go to insert course. Time slot. Takes, student, teaches, section, and course. Okay. So we'll add another record in here. And we'll try to use a department that doesn't exist. So instead of finance, we'll do JUM 101, and that's part of the jumping department. And it's allowing that. Okay, I'm going to have to look at that, because there is not a department called jumping, and so the foreign key constraint apparently is doing nothing right now. See, it should say SQL error. Okay, here we go. So we have to turn something on. There we go. There's always an extra step here. I would never have guessed that, so I'm glad I scrolled down. Okay. We'll just throw it at the top. We'll see if it even works. There we go, finally. So you have to turn this on, apparently. So here it says line 143. When we try to insert a new course for the jumping department, that fails because there is no jumping department. Okay, and then 291, we're trying to delete the biology department. That fails because we have 3 records related to the biology department. So we can't delete that. So let's say we want to change, or we want to add a jumping department, and then we'll convert those 3 courses from biology to jumping. That should fix everything. That should get around the foreign key constraint. But we can't insert records that'll reference nothing, and we can't delete records that need something that reference needs that has records that reference back to it, right? So we can't get rid of biology, or we can't get rid of the biology department until we get rid of all the biology records or change them to have a different department. So that's what we're going to do. So let's just do it at the bottom here so I don't have to keep scrolling. So before we can delete the biology department, we need to change the other courses to another department. And let's go ahead and make the jumping department so the other one can be inserted. And I just wanted to show you the foreign key constraint to see how to prevent it. And then this part where I'm adding a new department and changing these, I just want to show how doing that gets around the foreign key constraint. So when you see a foreign key constraint, you know that you're trying to do something that's going to cause problems. And there's a way around it. It's just fixing those problems ahead of time. Okay, so we don't need a new course, we need a new department. We will add the jumping department, and it'll be in the mushroom building, and they have a budget of 1. Okay, and so that should get rid of one of our foreign key constraints. Okay, and now we only have the one for trying to delete biology courses. So now we can insert the JUM 101. It's called investment banking, whoops, but it's from the jumping department. I just forgot to change the name. So how do we fix this one? We can't delete biology courses. No, we can't delete the biology department because these courses rely on that. We need to change these to jump courses, or to the jump department. Okay, so before we can delete biology, we need to update the course table, and we want to set dept name to jumping, and then it should let me delete the biology department. Okay. Make sure you clear this if you're running this, because it just stacks on top of each other every time you run it. Okay, so now I have no constraints triggered to block me from doing stuff because we have a jumping department, so I can add courses that use the jumping department. And I deleted the biology department because we don't need it anymore. There are no records referencing it. Alright, so foreign key constraints, real fun. We will continue on with part 2 here. We just have a little bit more to look at. And then we'll move on to part 3, which is joins. I think joins are introduced in that one. I made these, so I should know, right? Well, it just makes logical sense that that's next. Alright, so I'm going to end it here. You guys have a good day. Remember to email me if you have any questions or problems with the assignments. Also, if you are a programming major or a web technology major and you haven't scheduled an advising appointment with me or been cleared, you need to email me about that. Alright, thank you very much, and I'll see you next week.